let me walk you through this Olympiad math problem. This is a very beautiful one. 4 to the power of x minus 2 equals 40. You're looking at this particular problem and you're asked to find x. It will be very difficult for some persons to be able to wrap their heads around this. But in this video, I'm going to be showing you step by step how you're going to walk through this particular one. But the first law I want to remind you of is this particular law that says if I have a to the power of m minus n, this could be written as a to the power of m divided by a to the power of n. With that being said, this particular one on the left hand side can be written as 4 to the power of x divided by 4 to the power of 2. That's pretty simple, right? And this will be equals 40. So what will be the next thing I would like to do? 4 to the power of 2, that will be 16. So we have 4 to the power of x equals 16, then that will give us 40. Then if I multiply both sides by 16, the reason for that, I want to remove this denominator. So if I multiply both sides by 16, I multiply this way by 16, you can see that this and this will cancel out, leaving us with 4 to the power of x equals, what exactly is 40 by 16? Let's leave it like that because that will give us a very big number. But because I want to just make it simple, I'll just have it as 4 dots. Please, this dot is multiplication. Let me put it in the center. 16 is the same thing as 4 times 16. Let's keep it this way. So the next thing I want to do is to keep in mind you're looking for x. I will take the logarithms of both sides of the equation. Let me use this part. When I fill this part, then I'll take the board down. Let's keep going like that. So we have here to be the logarithm. I'll take the natural logarithm of both sides of the equation, or maybe just take the log of 4 to the power of x, and that's something to do for the right hand side. The log of, we have 40 by 16. Pretty good, right? Okay, so what is the law of logarithm we need to apply here? That is the product law. No, that's the power law. The power law says that if I have, say, logarithm of a number, say this argument a to a certain power, let's just use conventionally maybe b. It means that this b will in turn multiply the whole of the logarithm. So this will come over here. So I'll say b log a. So let's apply the law on the left hand side. We have x log 4 equals, here we have log 40 by 16. Beautiful. So what will be the next step? I want to divide both sides by 4 because my interest is to look for x. If I divide both sides by 4, I will also have this to be divided by 4. So this will literally cancel out with this, leaving us with x equals. Now this is what we're going to be doing some rigorous of computations. And now what we need to do on the numerator is to split this according to this particular law. Let me state it somewhere. I think if I have logarithms of AB, this will be the same thing as the log of A plus log of B. Yeah, so that's what I want to apply on the numerator. So I have log of 40 plus log of 16, and I will divide both sides by log of 4. So that means I can handle this individually. What I mean by that is that I could say x equals log of 40, since we have just single denominator, divided by log 4 plus log of 16 divided by log 4. That is beautiful. So now we can now take the board a bit. Let's take it up a little. Good. So it means that we're going to be using this part, then later we fall back to this part. I just hope you're not confused, okay? So I'm sorry I'm not able to divide the board appropriately. So what do we need to do at this particular point? Looking at this, let's leave this one for now. Let's focus on this. We have log 40 divided by log 4 plus 16. I could place it in exponent form by say 4 to the power of 2. And if I divide that by 4, because 4 to the power of 2 is 16, and I did that because I needed that to match up with this particular log 4. Obeying the power law, if I have log a, I think I stated it before, to a certain base, then this one comes over to multiply the whole logarithm. So you have log x log a. So here I'll bring this over here. I get x equals log 40 divided by log 4 divided by log 4. This is log, please. Plus, we have here to be 2 log 4 divided by log 4. You can see that log 4 and log 4 will cancel out. So you'll be left with x equals log 40 divided by log 4, then plus 2. Beautiful. I think we're making progress. What do you think we need to do next? This 40, I'm concerned about it. I have to think of the factors of 40. I know 4 by 10 will give us 40. Let me use that one. So I can have this to be log 4 by 10 divided by log 4, then plus 2. Okay, let's take it up. Let's take it up. So I know that this, according to the law of logarithms, if I have, I think I've stated that before, if I have this one log AB, it's same thing as splitting it to be log A plus log B. So I'm going to be splitting this log 40 by 10. Okay, so that will give us x equals, have log 4 plus log 10, all divided by log 4, then plus 2. This is the same thing as saying I can just separate it with this single denominator. So log 4 divided by log 4 plus log 10 divided by log 4, then plus 2. We know that this particular one will give us 1 because this will cancel out definitely. So we have x to be equal to 1 plus log 10 base or divided by log 4, then plus 2. If I sum up 2 and 1, that gives us 3. And if it gives us 3, what will be the next move? It is simple. Let's just put that's 1 down. 3 plus log 10 divided by log 4. Let's take the board up. Let's take it up. We're almost done. We're almost done. So let's use this part. Okay, looking at this one, which we have log 10, I think I can still do something about this one. I can split it further, making this one to become 2 times 5. 2 by 5 will give us that. So have this to be equal to 3 plus log 2 times 5. That will be 10. Also, let me just be treating the denominator alongside. I know for this denominator, I can still reduce that 4 or replace the 4 in exponent form as 2 to the power of 2. Obeying the law I've been stating of logarithm, the law of logarithms, product law, I can still have this one as x equals, I have this one to be 3 plus log 2 plus log 5. You still remember the law I just stated a few minutes ago. Power law I've stated before. This is coming over. So we have this as 2 log 2. So now x now will be equal to 3 plus, I can now take this individually, log 2 divided by 2 log 2 plus log 5 divided by 2 log 2. Okay, in this case, this one and this one will cancel. So I'll have x equal to 3 plus 1 over 2, then plus 1 over 2 log 5 base 2. How? It's simple, because if I have a logarithm, say log a divided by log b, I can still replace this as log a base b. That's what I did on this particular log 5 and log 2. And then this 1 over 2, here is 1, here is 2. That's how I got this. But then let's play with this particular one. If I have 3 plus 1 over 2, what's the answer for this? I think, let me do a short multiplication here. Sorry, plus 1 over 2. 2 times 3, that will be 6. Plus 1 times 1, that will be 1, divided by, you have to be 2. 1 times 2, that's 2. So this gives us 7 over 2. So I have, let's go up here, x equal to 7 over 2, 7 divided by 2, plus 1 over 2 log 5 base 2. So because they're having the common denominator, which is 2, I can add 7 plus this one. So I can have x to be equal to 7 plus log 5 base 2, all divided by 2. So I want to check if this answer, if this value is actually correct. How do we check if the value is correct? You want to go back to the original equation to see that if you plug this value of x for the left hand side, where you have, I think this is equation 4 to the power of x minus 2 equals 40. If you plug this value of x on this particular to replace this x, if this left hand side is going to give us 40. Let's do that quick computation. Okay, so the first thing I want to do is to plug in that value. So 4 to the power of, what's the value of x? Let's check that very quick. So the value is 7 plus log 5 base 2 divided by 2. Then we have everything minus 2. Okay, that is it. I want to check if this will give us 40. Is this going to give us 40? We don't know. So let's check that out. So what is going to happen here is that I'm having this to be a fraction. If I make this to be a fraction, you can see that the LCM of 2 and 1 is just 2. So I will just simply have 2, and 2 into 2 here is 1. 1 times the whole of this will still give us 7 plus log 5 base 2, and then minus 1 into 2 will be 2. 2 times 2 gives us 4, and then we're just having 4. Okay, keep in mind this particular sign, this division sign is going to cover everything here. Okay, so we want to check if that will still give us 40. Let's be going step by step. Okay, here 7 minus 4 will give us 3. So we have 4 to the power of 3 plus log 5 base 2. Where is the L? Okay, this is it. Okay, divided by 2. If this divided by 2, then we have this. Is it going to give us 40? We don't know. Let's keep working. So at this point, I'm concerned about this 4. We can keep it in exponent form, 2 to the power of 2. And I have reasons to do that. Remember, I'm just concerned about this left hand side. Let me say I can solve it until it gives us 40. If it doesn't work, it means the solution is not correct. So here you can see that this one can easily cancel out with this particular one. I'm going to be using the rules you understand, you know. If you don't know it, it's not a problem. We're going to be learning some of the rules right now. So log 5 base 2, but I'm going to be taking it step by step. Is this equal to 40? We don't know. 17, is this equal to 40? We don't know. Okay, so let's keep going. I want to apply product rule of indices over here, because if I have say maybe a to the power of m plus n, I can as well keep that to be a to the power of m multiplied by a to the power of n. So let's do that here. 2 to the power of 3 multiplied by 2 to the power of log 5 base 2. Is it still going to give us 40? We don't know. Let's keep going. What is 2 to the power of 3? That gives you 8. That's 2 times 2 times 2. That will multiply by, what about this? There's this law of logarithm that says if I have a to the power of log, say this argument b base a. So what happened? This will just give us, because this is a base of this logarithm, then this will neutralize, giving us just b. So that way, if I have 2 log 5 base 2, look at the argument 5, and we have common base here, this will initialize to give us, neutralize to give us 5. Is this still going to give us 40? Okay, what is 8 times 5? That's 40. So 40 equals to 40. That means x equals, here's the answer. X equals 7 plus log 5 base 2 divided by 2 satisfies that problem. Satisfy that problem. Where's the problem? This problem we're having here. So it is correct. I hope that makes sense. Please, if you are just joining us for the first time, please consider to follow us for more updates like this, and try to repost this particular video so that audience that needs this particular one to pass the exams will definitely want to engage in our posts. And then don't forget to link me up if you have opportunity, if you have a teaching assistantship, if you see where post is being made about fully funded scholarship, research assistants, and all of that. I'm still actively available. If you have a child, or you have a ward, or if you have a friend who is looking for SAT tutor, you're looking for somebody who is going to teach maybe GCSE exams, IGCSE, whether A level, year 1, year 2, year 3, year 12, any level, whether college, you're having maybe people in the university, I'm actively available to work with you on one-on-one section. If you want to join ASVAB Telegram platform where I'm posting videos and gray, or you want to join our Olympiad Telegram platform, sign up for our class. Thank you so much for participating in today's class. Until next time I meet you, I will see you on the next one. Please make sure to repost and like this. Bye, and take care of yourself.